This is a NEET 2016 question in gravitation. A satellite of mass m orbiting on the Earth at a height h from its surface. Total energy of the satellite in terms of g naught. The value of acceleration due to gravity on the surface of the Earth is how much? Right? So what he is saying is, there is Earth whose radius is r, mass is m. At a height h from the Earth, there is satellite of another mass who is revolving around the Earth with a certain velocity, obviously, which is called orbital velocity. Now, what is the total energy that it has? As it is having certain position from the center of the Earth, it has potential energy. As it is moving, it has kinetic energy also. So, what we can say? Total energy of the satellite is sum of gravitational potential energy and kinetic energy. I know that for the gravitational formula for the gravitational potential energy is minus gmm by r plus h, because it's at a height h. From the center, the distance is r plus h. Kinetic energy is half m v orbital square. Where what is that v orbital is? V orbital is the orbital velocity, that is root of gm by r plus h. Where r plus h is again the height from the center to the object. Be careful, it's not root gm by r, root gm by distance from center to that planet, that is root gm by r plus h. I can substitute this value in this here. That implies what happens to total energy is minus gmm by r plus h plus half m v orbital square is gm by r plus h. So what I can take common is gmm in both of them. If I have taken gmm common, minus 1 by r plus h plus 1 by 2 of r plus h is remaining. So gmm of LCM is 2 of r plus h. This becomes minus 2 plus 1. So minus 2 plus 1 is minus 1. So minus gmm by 2 of r plus h is my answer. But he wanted in terms of g naught. What is that g naught is? Where that's the relation between small g and capital G. When the body is at a particular place, in the place of g, I can write here we can write a relation, that relation between small g and capital G is g equal to gm by r square. So in the place of gm, you can write gr square. I can write that here, right? It implies total energy is minus gr square, and this m is there, and 2 of r plus h is there. So my answer is minus gm square r square by minus gm r square by 2 of r plus h. Option B is the answer for the problem. So it's a simple problem. Only we need to know the formulas for potential energy, kinetic energy, and formula for orbital velocity. Once you know them, you can substitute and get our answer as shown in option 2 of the problem. That's it. Thank you for watching.